Um, so on our agenda for the afternoon, our first talk will be a team from Servier who will be discussing updates to the Servier Service Planning Toolkit. And then at 3:15 p.m. Eastern, we will have presenters from the Valuables Consortium who will speak with us about measuring how Earth observations benefit society. Both of these presentations will have an interactive component. And without further ado, I'm actually going to stop my share and Helen, you can share your screen. Uh, Please welcome the team from Servier, who will be speaking with us about Servier's approach to designing inclusive geospatial services.
Awesome, thank you so much.
Oh, and Helen,
right?
Yes, I can see your screen. It looks perfect. And if everyone who's presenting could briefly introduce themselves to our listeners, that would be great.
Awesome. I just realized I didn't do what we need to do for sharing with sound. So forgive me and one more minute. 1 second. All right, can you see that all right?
Looks good.
All right, well, thank you guys so much. I'm Helen Parachi. I'm working at the Science Coordination Office in Huntsville, Alabama, and just filling in for Emily Adams today. So we will be talking about Servier's approach to designing inclusive geospatial services. We'll start with just a brief introduction to Servier and then move into an introduction to the Service Planning Toolkit that we use at Servier. And then we'll have 3 presentations that look at this toolkit in action. And finally, at the end, we'll have that interactive portion where we break out into different groups and can discuss and then come back together with our main ideas. So I'll give this brief introduction to Servier. Servier is a joint initiative of NASA and USAID, and we work in partnership with leading regional organizations around the globe, helping countries apply Earth observations and geospatial technologies for environmental management. Servier connects space to village by helping countries use satellite information to address critical challenges across 4 themes: agriculture and food security, water and water-related disasters, land cover and ecosystems, and weather and climate. Since 2005, Servier has grown into a global network of regional hubs that support analysis and capacity building to connect satellite data to development challenges in South America, West Africa, Eastern and Southern Africa, and the Hindu Kush Himalaya region, and Lower Mekong region as well. Is on U.S. scientific leadership. We rely on our applied science teams that are chosen in a competitive way to bring the best science possible to our network. And we really focus on the co-development of these applied science teams with our regional hubs to make sure that our services most benefit our hubs. Servier also works to make geospatial technologies and professions more gender responsive, inclusive, and equal. We build women leaders and gender champions in Servier. We empower women and girls to explore STEM fields. And most importantly for this conversation today, we integrate gender considerations in service planning through gender analyses and participatory review. And in addition, we use remote sensing and GIS to address development issues that are inclusive of underrepresented groups characterized by gender, ethnicity, age, and/or social status. Servier looks to further expand our impact. So we really want to build lasting institutional capacity to address climate change and resilience. You see here we have science and data on one side and end user needs on the other. We really want to bridge that gap. And this includes building institutional as well as individual capacity to take up the different innovative solutions that our AST members and our network members develop. So this really comes into this co-development where we co-develop replicable, adaptable solutions and bring them to scale and capture opportunities from upcoming missions. We augment the US government priorities in new regions based on the momentum built by the program and continue to help countries build resilience and adapt to a changing environment. really taking into account, of course, the needs of the end user. So this is something that we'll talk about a lot today, the needs of the end user. But often with science, we have these really great ideas. We have these scientists that will come up with a solution to what they see is as the problem, and then disseminate that to the world, just make it available. However, we really need to make sure that since the scientists and the people using the tools are often not the same people, that we take into account the needs of those end users and their ability to use the products that we create. So when we create these tools, often if we miss this end user step, we have a bunch of tools that end up in the graveyard, unfortunately, even though they might be really awesome and have the best of intentions. And we need to make sure that our tools are actually in use. And so this end user engagement is extremely important. And so to go into a little bit more about how we avoid that graveyard, I'm going to pass it over to Georgia. Thank you very much.
Awesome. Thank you, Helen. Hi, everybody. My name is Georgia Hartman. I work closely with Helen and with Emily Adams on Servier, and I am a Gender Environment Technical Advisor at the Gender Equality and Women's Empowerment Hub at USAID. Yeah, and I help manage these activities. So I'm going to give a little bit of a broad overview of Servier's efforts to build out a gender inclusive service planning toolkit. So slide. So with Servier, USAID and NASA are partnering to make a development impact that reaches all communities. We do this by developing services that use geospatial data to monitor local challenges related to climate change. But before we can develop a service, we must understand the development challenge or need in the regions where we work. In order to do that, we need to establish a working relationship with the potential users of the service and start engaging with them as active co-developers. And we also need to identify and engage the full spectrum of stakeholders, future users, and complementary initiatives. Then we need strong design to put our plans into action. And finally, we need to have a clear goal for our service and a way to measure impact. So to accomplish this, Servier developed the Service Planning Toolkit to outline our approach to all of these steps. And it's what Servier has used to develop more than 40 services at our 5 hubs, engaging hundreds of colleagues and thousands of stakeholders since 2017. So I think now you're on the right slide. This presentation will give you an overview of Servier's approach to developing inclusive geospatial services, as outlined in the Service Planning Toolkit. The toolkit has 4 tools that are designed to be used in an iterative way. That means revisiting the different stages of service planning to refine the approach is an expected and encouraged part of the process, as you can see represented in this circular model on the slide. I will now walk through the 4 stages of service planning, highlight what the toolkit includes. I think, yeah, this is fine. I will now walk through the 4 stages of service planning, highlight what the tool includes to support the application of this approach, and share some insights from the first update to the toolkit. It's our hope that sharing this approach will give you ideas for supporting your current work to make it more responsive to local needs and more inclusive of users, as well as the communities impacted, and ultimately make it more effective, hopefully. Slide. So yes, intro overview. Next slide. The first stage of service planning is consultation and needs assessment. At this stage, we seek to identify the development challenge the service will address, as well as the key actors that need to be involved to co-develop the service with us. This is the stage where we ask questions such as, who are the key stakeholders and how are they currently making decisions? What information are stakeholders using and where are there gaps in information or capacity? And finally, how can we build on or complement other activities? Through consultation and needs assessment activities, we establish key relationships that will be maintained throughout the service design and delivery process. And by engaging the end users from the beginning, we ensure that the products we develop meet the clearly expressed need, and that we have partners to work with when the products under this service are ready for use. So this is a way in which we're thinking about sustainability from the very start. Bye. The service planning toolkit includes ideas and consultation approaches, such as workshops, key influences for meetings, surveys, and focus groups, and workshop resources like guidance on how to conduct a consultative workshop, which includes even down to a sample agenda, group work exercises on problem identification and prioritization, and a report template for capturing discussions. Slide. Once we understand the needs and actors, we use stakeholder mapping to make sense of the complex landscape of stakeholders, how they work, what their decision-making processes are, and identify where Servier fits into this process. Slide. To support stakeholder mapping, the toolkit includes tips for how to do stakeholder mapping in a workshop setting and provides guidance on how to visualize stakeholder roles and responsibilities. Slide. Now that we know our actors, understand how they work together and how decisions are made, we enter into service design for real. The goal for this phase is to unite our hub teams and users in a collaborative process to outline the the service design, development, and implementation. In this stage, we answer questions such as, who is the service for? Which stakeholders will be engaged? What decisions will it inform? And how will the information be delivered? Slide. To support service design, the toolkit includes a Servier concept template that articulates the service vision and how it will lead to impact, and 3 definition documents that specify the technical details and other activities related to the various components of a service, including products, data management, and training and capacity building. Slide. In order to understand the impact of our service and to learn through implementation, we use monitoring, evaluation, and learning, or MEL for short. At this phase in service planning, we create, collect, and report on relevant performance indicators and nurture a culture of asking challenging questions and having evidence to support responses. This stage of service planning focuses on developing a theory of change. A theory of change maps out in detail how activities and interventions will lead to impact. So our theory of the change that we hope to see. It is both a process and a product. It is a collaborative exercise to systematically think through how to achieve the desired change. It is also a product in that it results in a visual representation of the steps and logic behind them to achieve change. So ideally, this will be a resource that we'll keep tacking back to. Next slide. To support the development of theories of change, the toolkit includes steps to develop the theory of change, including a theory of change template, along with guidance on selecting indicators. Slide. Servier has been implementing the service planning approach since 2017, but over time, the network struggled to make the design processes more inclusive of women and other populations, and to have a concrete way to make sure that the needs of people differentiated by gender, age, class, minority status, etc., were all benefiting equally. In order for geospatial services to truly address development challenges, the distinct issues facing women and other populations that contribute to their vulnerability and/or resilience to climate extremes need to be understood and addressed. So we spent the pandemic collecting case studies of how we and our partners have achieved inclusive services, and we reviewed the toolkit text to see where we could make the guidance more intentionally inclusive by adding approaches, examples, and adjusting language and template prompts. Slide. We learned that there are lots of ways to include women in the service planning process. Firstly, we have many opportunities to engage women as stakeholders and users. We can establish communities of practice for women working in the geospatial sector. We can organize women-only trainings to create a supportive space for women to gain new skills. We can partner with an organization that brings sex disaggregated data to complement our own. And we can be proactive or even retroactive about inclusion at the consultation and needs assessment and stakeholder mapping phases. Second, we can use the iterative nature of the service planning approach to support more inclusive services. The cyclical nature of service planning provides recurring opportunities to assess the varied impact of a service based on gender and the representation of women in the co-design process. Third, we have opportunities to better understand the development challenges of women and other communities. We can use surveys to understand varied impacts or varied modes of access to technology and ways of receiving information. We can use separate focus groups for men and women to ensure that all voices are heard and all feel comfortable speaking up. We can use sex disaggregated data, which can be difficult to come across sometimes, but ideally. And we can and should consider stakeholder intersectionality, so the way that different identities intersect with one another, and how that contributes to vulnerability. Finally, we will continue learning through implementation. The majority of Servier services to date addressed gender during implementation and not planning. In light of this, conducting a gender analysis can be useful. Involving gender advisors at all stages of service planning is considered an advantage, and not knowing the answer, but asking the question, can be an important first step to developing inclusive services. So, thank you. Helen?
Are you able to see the slides? Is that?
Yes, we see them not in presentation mode,
Yes.
but they're Helen. Mm-hmm.
Okay. I'm sorry, Georgia, did you complete your section?
Yes, sorry, I thought it was past, I thought the next slide was yours too.
Oh, was it?
To do the transition, but I could be wrong, sorry.
Yeah, so no, I think maybe it was my misunderstanding. Sorry, picking up from Emily, we didn't have very much overlap time to chat before she left. So basically, we do have this 2021 revision to the Servir Service Planning Toolkit, and it has these different use case studies. And what we wanted to do today was to look at these different use cases that we've selected from all of the use cases that we gathered. We have a few to share with you today that highlight different parts of the toolkit that Georgia just described. So we have that consultation and needs assessment. And so today we'll be sharing the use case from Servir Amazonia, ecosystem services modeling in the Amazon's forest agricultural interface. And for the stakeholder section, we'll be having the rangeland assessment and monitoring service. We'll be highlighting that service. And then finally, we'll have the monitoring, evaluation, and learning section of the toolkit. We'll be showing that in action, looking at Servier Mekong and the enhancing drought resilience and crop yield security for the lower Mekong service. So unfortunately, we won't be discussing service design so much today, but we will get to those other sections of the toolkit and see those use cases presented today, and then have a chance to discuss on these topics at the end. So I'm going to turn it over to Jose. If you are able to present, I'm going to turn myself silent. And Jose, if you are available.
Yes, thank you, Ellen. Can you hear me?
You sound great to me.
Yes, perfect. So let's start. So thank you for this opportunity. It's a pleasure to be here. I'm José Fernandes, the Servir Amazonia User Engagement Lead. I work for the Alliance Bioverse International and the International Center for Tropical Agriculture, and I'm based in São Paulo, Brazil. So next, please. So I will focus on the consultation needs assessment in action, focus on the service known as ecosystem services modeling in the Amazon's forest agriculture interface. Next, please. So I hope in the end of this presentation to provide answers for these three questions. How does the consultation process and identification of needs with users take place? Why is such a process important for service co-development? And what are the drivers for service sustainability? Next, please. So for Servir Amazonia, engagement activities through user consultation and needs assessment are very important and prior to the development of sustainable process for the co-development of services. Without engagement, it's very difficult to advance in an organized way in the development of services. So we start with the user needs assessment, and then we go to prioritization of service ideas, and then we go targeting engagement for the key institutions to work with. The next, please. So the service ecosystem services modeling in the Amazon Forest Agriculture interface is the one we are considering as a reference for this presentation, co-developed with the Brazilian institutions like Embrapa and Peruvian like Aliança Cacau and Cernampi. The next, please. If you need or if you want to have further information about the service, you can consult the Servier service catalog. So basically, the Servir Amazonia Hub is using the Service Planning Toolkit. So with the scope of the service use as an example, we carry out a user needs assessment workshop in Brazil and in Peru for the validation of the rapid stock taken, as well as for the arrival of the NASA Applied Science Team initiative, in your example here, led by Dr. Nayara Pinto from NASA JPL, which scientifically guided the engagement with key users and co-implementers. The final goal of the consultation workshop is to get up with a list of services, service needs and service ideas elaborated in a participative way. The next, please. So with the country's lists of service ideas in hand, Servir Amazonia Hub proceed with the prioritization of service ideas according to these criteria we can see here in this slide. So the prioritization of service ideas has been given jointly with the AST teams and the technical teams of the different key stakeholders of the identified services. And for the service case here, Embrapa Brazil and Minam Peru were invited to participate in this prioritization exercise. The next, please. The next step is face-to-face meetings with key organizations or key institutions. For the service case here, we spoke with several Embrapa units, Aliança Cacau, among others, to present the NASA AST initiative, as well as the service list that interact somehow with the mission of these institutions. Focus on understanding the needs and agreeing on the next formalization steps, which can take months to years, depending on the service and key organization that we are dealing with. The next slide, please. Then we went to a formalization of partnerships for the co-development of services towards to institutionalization of services and products. MOUs, Memorandums of Understanding, give us some institutional support and commitment to technical activities. There is also a certain level of transparency, accountability, and empowerment that is obtained through the visibility that's given to the signing of MOUs. The MOUs will somehow waterproof us against the institutional and political change of our main partners. So we consider that we are working with a long-term vision. In this context, the co-development process is only structured once the co-implementing organizations understanding their role in the service conceptual note or work plan that we elaborated together with their technicians. The formalization of partnerships through the sign of MOUs generate a commitment to the co-development and co-delivery of service. However, for the sustainability of services, a step forward is needed. That is, it's necessary with the co-implementing organizations to appropriate the services and the scientific ideas behind it, in addition to a robust plan for the socialization and dissemination of the services through a training sessions toward to use of the service with users, users of users, beneficiaries, and decision makers who see themselves identify with the functionalities or features of the service. So this is the presentation. I'm happy to provide further information as necessary. So thank you very much.
Thank you so much, Jose. So now we'll hear from Lillian. And please let me know if you have any issues with the sound.
Hello everyone, my name is Lillian Dongo and I'll be Hello everyone, my name is Lillian Dongo and I'll be talking about the Kenya Rangelands Monitoring and Forecasting Service. The service began through consultations in 2015 when challenges in monitoring the vegetation condition and the ground and surface water availability was identified by the stakeholders that were part of the meeting, and the service prioritization was based on availability of data and the temporal and spatial needs identified through the consultations. The service therefore seeks to provide the information that is required for decision making, and this information includes vegetation conditions, drought situation, location of water, of surface water resources and water availability, the condition of groundwater resources, and the extent of an unpalatable invasive species, as well as any other ancillary information that is required to support interpretation. And this information is used to support different decisions, such as forecasting pasture availability, managing drought, developing and revising grazing plans, as well as managing the movement of livestock and dissemination of required interventions, and also implementing and monitoring conservation measures to rehabilitate the degraded lands, as well as management of scarce water resources and mitigation of the spread of invasive species. And this is achieved through two things: the development of the rangeland decision support tool and required functionality to support the specified decisions, and also capacity building through different modules such as technical trainings of trainers, especially at the county level, and awareness exercises. And stakeholder consultations to refine and to continue understanding the evolving needs of our stakeholders take different forms. This could be informal or informal meetings, focus group discussions, virtual consultations, and even active participation in meetings that are being held by stakeholders to understand their challenges and to understand how we can contribute towards responding to those challenges. And the result from this is that we have continued to identify stakeholders who realize and add value to the service, and also new synergies that have resulted in strengthening the service implementation and technical developments. For example, we collaborated with the University of Sussex to develop the VCI forecast at district level, and with the workflows, with teams from both ends co-developing and implementing the workflows, and with plans to further downscale these forecasts from county to sub-county level. And again, through the PREG partners, mapping of county grazing resources and supporting the counties in their ward mapping processes, as well as building their capacity in the use of GIS and ICT technologies to monitor and map the rangeland resources. But also improving data collection by the National Drought Management Authority officers, contributing to an already operational network, but adding value and additional information to support drought management. There has also been the work that has been done together with Kenya Rapid, that is digitization of grazing areas, the wet and dry grazing areas in 5 northern Kenya counties, as well as visible growth in terms of stakeholder buy-in. For example, counties have been funding training of their officers in GIS skills, and Also leveraging on the existing capacity within the counties to do training of trainers who can sustain the technical requirements for GIS and for rangeland resource mapping. And further, HCMRD has also been engaged in assisting the counties such as Wajir in setting up their own GIS labs. But we've also seen a growth in the number of products in the tools, such as the forecast. There's also an ongoing improvement of the surface water components and all the other rangeland indicators, as well as applied science team collaborations in forage assessments. And the stakeholder roles are actually cross-cutting, with specific organizations being both decision makers and users of the information that is coming out of the rangeland monitoring and forecasting service. These include the Northern Rangelands Trust, the Laikipia Wildlife Forum, and these would be the conservancy owners and managers, Kenya Rapid and Masico at the national level, the National Drought Management Authority, county governments, and rangeland management committees, with the lower level officers being users and beneficiaries, such as the county officers, the local communities, the grazing coordinators, and local conservation groups. And there has also been service integration, such as inputs from the invasive species modeling, but also collaborations with the weather and climate team in groundwater resource monitoring. And the stakeholders have actually grown. We began with consultations with a few stakeholders, and these stakeholders have actually grown, and their role in the use and sustainability of the service evolving over time. And what we have seen is that there have been a lot of growth and dynamism in the service from its inception up to this point. We've seen a growth in the way that it's being applied to make decisions. We have improved the functionality, the platforms, and the stakeholders have also grown with their roles and level of engagement changing over time, but also the scale of the monitoring changing, with coverage for the monitoring for the service components covering the entire country, but also there has been downscaling of the functionality to a lower level to support the different decision-making needs. And we are also again shifting from the platform that we were using before to a more dynamic platform that would allow for integration of the new components that are being developed through different collaborations. Thank you.
All right, well, thank you very much for that. And we will now hear from Ikapo. And please, again, let me know if you have any issues with the sound.
Hello, everyone. In this session, we will talk about monitoring, evaluation, and learning tool in action, which we use a case study from Servier Mekong. So the goal of MEL, there are several goals, but the goals that we want to focus on today are to identify the steps of the service from a change perspective, and to identify measurements for determining progress by using theory of change and result change. And result change is a graphic representation of a theory of change. See an example here. So let's develop a theory of change by using a result change for this service, which is enhancing drought resilience and crop yield security for the lower Mekong region. Okay, let's first identify the impact. Here, the impact we want to see is to improve farmers' livelihood. And in order to that to happen, this is the reduction result. The water resources and crop yields should be better managed. In order for that to happen, the farmers in the Mekong countries will have to apply the new water and farm management practices for crop cultivation. And we need help from the government for that to happen. The government needs to improve the policies or standards for agricultural productivities. There are many ways for this that this can be done, but for our service, we design the service so that here we develop the tools, the crop yield forecasting tool and drought forecasting tool for them to use, to uptake, so that they can improve the policy. And the other thing that we do is to improve institutional capacity for these organizations, and not just the countries in the region. We need the whole region, so we need a regional organization to be part of this as well. And the last thing is gender consideration. We need that to be integrated into decision-making process. So now we have the result chain for this service. The next thing is to develop MEL framework for service within the project time frame. So some of the results, like impact, might not happen within the time frame. So we have to pick the results that we want to monitor. Here, so we have to identify the highest result that we want to see within the time frame, which is the improved policy or standard. We set that as an objective of this service, within the time frame. Okay, let's see. And then we identify which results are the outputs and which results are the outcomes. The next thing is to identify the indicators and targets. So for example, for tool development, we have the indicator, which is very straightforward, which is the number of tools that we developed, this crop yield tool and the drought forecasting tool. So we expect that we set the target that these two tools or innovation will happen by the year 2019. Same thing is the capacity building. We want to train 100 people by 2019 as well. Okay, for the outcomes, for example, we want to set uptake by 3 organizations here, as in the circle. And for the capacity development, we want to see 3 organizations with improved capacity by the year 2020. Okay, for gender consideration, we want to see the plan or guidelines or policies to be proposed by the year 2021, at least one. And for the objective, we want to see a law, policy, or regulations to be proposed, adopted, or implemented by next year or 2022. And for this, we list all the indicators and we monitor the target, like how the progress in percentage. And here's an example of the table that we use. So thank you very much.
Well, thank you so much for that. So now we're going to go into our interactive section. So we're going to create 3 breakout groups. The first is a consultation and needs assessment group. So we'll be discussing the consultation and needs assessment part of the Service Planning Toolkit, and this will be led by Jose. And then the second will be stakeholder mapping. And I believe Georgia actually has to leave at the top of the hour, but I will still be in that session. So I hope to see you there. And then third, we'll have monitoring, evaluation, and learning, which will be led by Amanda Markert. So if you could please enter the number of your preferred breakout in the group in the chat, and then Sydney will move you to that room. I believe we have, and please correct me if I'm wrong, Brendy, but I believe we have 15 minutes left. I had hoped to come back and share, but I think that pushes us a little bit too hard in our discussions. So group leads, if you don't mind sharing some of your key highlights or notes that you took during the session with me afterwards, that would be really appreciated. so that we can have some kind of consensus from this. So we'll have about 15 minutes to do our breakout sessions. And again, please enter the number of your preferred group in the chat and you will be moved to that room. Please let me know if you have any questions, or maybe Sydney can help with that as well. Thank you.
So next up, we have Bethany Maybe, Deputy Director of the Valuables Consortium, and Yusuke Koyama, Resources for the Future Fellow and Valuables Consortium Director, who will be speaking to us about measuring how Earth observations benefit society with the Valuables Consortium. I was told that you'll be sharing your own slides, so if someone would like to share your screen.
I'll be doing that, and thank you so much for the kind introduction. And we're really delighted to be here today, joining the NASA Applied Sciences community. And let me just pull up our presentation. And while I do that, I'll say, on behalf of the Valuables team, thanks to our NASA hosts and to those on the line for joining us today. We're really delighted to be here. So I'll kick off our session with an overview of the Valuables Consortium, our work, and a look at some of the exciting projects that the larger Valuables community has underway. I'll then be turning things over to my colleague, Yusuke Koyama, who directs Valuables, and Yusuke will be introducing the impact assessment framework that Valuables has developed as a tool that you can use to measure how your work benefits society. And so after he does that, he'll be leading an interactive discussion session with everyone in today's session to demonstrate how you can use this tool in practice with a couple of concrete examples that we have prepared for you. So I'll begin today by introducing the Valuables Consortium to those of you who are not familiar with us. Valuables is working to measure and communicate how satellite information benefits people and the environment when we use it to make decisions. So Valuables is a cooperative agreement between Resources for the Future and NASA, and we're currently in our 5th year. And for those of you who are not familiar with RFF, we are a nonpartisan, nonprofit research organization based in Washington, D.C. We bring together the world's largest community of PhD economists who are focused on environmental and natural resource issues. So let me just highlight for you quickly a couple of key elements of Valuables. We are a uniquely large multi-year effort to quantify the socioeconomic benefits of Earth observations. And our focus on measurement is one of the things that really distinguishes our work from some of the other important efforts that are underway to document how Earth observations are used. And we're particularly interested in quantifying what we call socioeconomically meaningful benefits. So these are things that matter to people or to the environment. And some examples are things like lives saved, increase in profits, acres of forest conserved, or an increase in crop yields, for example. So we are not focused on things like peer-reviewed publications or an improved understanding of a natural or physical system. We certainly appreciate the importance of these things, but we don't define them as having socioeconomically meaningful benefits in and of themselves. Valuables conducts 2 main types of activities. First, we are producing new case studies, which we call impact assessments. And these are microeconomic studies that provide quantitative estimates of the value of using satellite information in specific decision contexts. So these studies have 2 key components. One is to document how people use improved information to make decisions. And the second is to quantify how these decisions improve socioeconomically meaningful outcomes. Our other key area of focus is on capacity and community building activities. So here we are working with the earth science community to increase people's familiarity with the key terms, concepts, and methods that are associated with impact assessments. And we're also building an interdisciplinary community of earth and social scientists and decision makers and practitioners such as yourselves who are interested in and prepared to conduct this work. So this is an overview of how the consortium is structured. Our core team includes experts from RFF and NASA. We also benefit from the expertise of an external scientific council. These are earth and social science thought leaders who serve in an advisory and outreach role. Council members come from NASA, other federal agencies, academia, as well as the private sector. Valuables Consortium members are institutions with relevant interests and/or activities that help advance the consortium's work. And finally, the Valuables Community of Practice, which is the broadest group affiliated with the consortium, is made up of people like you. It includes practitioners of value of information approaches and those working on to develop relevant projects, tools, and activities. I invite you to learn more about the consortium at rff.org/valuables. This is a high-level snapshot of valuable studies, which address a range of applications, including endangered species, water quality, wildfires, agriculture, and air quality. So this slide shows both the questions these studies ask paired with the results they find. These studies are all available at the website listed here, and I'll note that a number have already been published in peer-reviewed journals. Others have been submitted or are in preparation to be submitted. So today I want to highlight for you the first study displayed here, which was released in April as a working paper and authored by Richard Birnkoff, Yusuke Koyama, and Andrew Steinkruger. So this study looks at how satellite data could be used to help commercial marine shippers comply with future regulations to conserve endangered blue whales off the Pacific coast at lower cost. The study investigates adjusting shipping limits, speed limits of shipping vessels at critical times and locations to avoid fatal collisions with whales. So it's comparing two different states of the world, one in which vessel speed limits depend on whale distribution data from shipboard surveys, and another where speed limits depend on whale distributions predicted by a federal data product you may be familiar with, called Whale Watch, which incorporates information from remote sensing to identify more precisely where whales are located in time and space, enabling their conservation at lower cost. So this study finds that the value of information of Whale Watch ranges from $21 million to $332 million in 2017, depending on the conservation goals of the modeled regulation. So turning from valuable studies, I want to highlight some of the great impact assessments that members of the consortium community have underway. Last June, Valuables announced the winners of grant competition designed to support research that quantifies the benefits of using satellite data in decisions that improve socioeconomic outcomes. So we received submissions from 41 teams, and following a 2-round proposal process with an external peer review, we funded 3 interdisciplinary teams of researchers representing 14 different institutions. So briefly, Sonia Aziz at Moravian College is leading a field experiment to quantify the benefits of using a satellite-driven early warning system for cholera in Bangladesh. Jill Caviglia-Harris at Salisbury University is leading a project to estimate the societal benefits of satellite imagery that's used to enforce the Brazilian Forest Code and reduce deforestation. Steve Newbold at the University of Wyoming is leading a project focused on satellite data for harmful algal bloom early warning systems. And I'll note that Valuables is also supporting impact assessment work on the value of satellite data for disease eradication and designing habitat corridors for migratory species. There's additional work underway to measure the value of remotely sensed evapotranspiration data for managing water transfers in New Mexico. And we're excited finally about a collaboration with Andrew Krechkowitz at Columbia University, who leads the NASA Geo Flash Flood project on the value of flash flood risk information for the humanitarian sector. So turning from these community-led impact assessments, I want to highlight a line of written resources that are available to you now, if you're interested in exploring how to measure the value of the scientific information that your projects might be generating using impact assessment concepts and techniques. So the consortium's Value of Science Explainer series is designed to introduce key economic concepts and methods that inform our approach to impact assessments, as well as the consortium's impact assessment framework. You can find the current installments in our explainer series at these URLs here. And I welcome you to sign up for Valuables community newsletter, where we'll be releasing new explainers in the coming weeks. And I'll be happy to drop that URL in the chat in a few minutes. And finally, I want to note that if you're starting to see the potential for designing your own impact assessment after learning a bit more about some of these studies, and after today's session, I want to encourage you to register for NASA's 2021 Space Apps Challenge at spaceappschallenge.org. The Valuables team is excited to have a challenge in the event this year, which takes place October 2nd and 3rd. So with that, I want to turn things over to Yusuke, who will be introducing the Valuables Impact Assessment Framework.
Thank you, Bethany. Can you hear me okay?
We can.
All right. So yeah, thanks Bethany for that introduction. Again, my name is Yusuke Kuwayama. I'm the director of the Valuables Consortium. I'm a fellow at Resources for the Future and an assistant professor at the University of Maryland, Baltimore County. And I'd like to thank NASA and the organizers of NASA Applied Science Week for the opportunity to share a little bit, for those of you who aren't familiar with the Valuables Consortium already, some of the work that we do, and what I'll be talking about in a minute, which is the Valuables framework, which is the key framework that those of us in the Valuables Consortium, together with the other elements of the consortium that Bethany described, that comprise the structure of the Valuables, have arrived at now in our final year of the consortium as the key tool to help the earth science community and the social science community work together to help characterize and quantify the benefits of satellite data in decision making. And yes, thanks also to all of you for joining us today in this session. So yeah, Bethany, I think we can move on to the next slide, which is the framework. This framework is something that we've arrived at after several other earlier versions of the framework that we've piloted with various audiences, and this is the one which we arrived at. We decided that this would be the sort of the final framework that we'd settle on because of its flexibility and its ability to accommodate a variety of different kinds of earth science applications and decision contexts, but also it seemed, at least visually, what works best in order to both introduce the concepts of impact assessment to folks who are new to this process, and also very effective at summarizing the results of completed impact assessments and the logic behind why those results are what the impact assessment arrives at. So let me take some time here to explain what this grid-like framework, how it works. And I want this to be as interactive as possible. So I believe the chat is now functioning, so feel free to type in any questions that you may have as we go along here. I'll be keeping an eye on it, and Bethany, you will as well. But yeah, again, we have a good chunk of time left in this session, 45 minutes, I guess, to go through this. So I think one of the benefits of this format, this sort of breakout session type format, is that there aren't too many of us here. So we certainly have the ability to answer questions and try to go through a number of examples so that this concept hopefully is helpful to those of you who haven't seen it before. Okay. So the basic so yeah, let's focus first on the vertical columns here, right? So there's sort of a bluish column here and a red column, reddish column here. And so along these columns are sort of what the term that Bethany used earlier, the two states of the world. Okay, so the blue is one state of the world, the red is the other state of the world, and we want to be able to describe along these rows the information, the decision maker actions, and the outcomes for people and the environment that take place in these two states of the world. And these two states of the world are characterized by a world in which the information that we are trying to assess exists and is used in decision making, and the other world is a world in which the information does not exist and is therefore unavailable for decision making. And so, obviously, if you are someone who is interested in conducting an impact assessment of a specific data product or data system or data set or a model of some sort, then you already know what that piece of information is, right, that you're trying to assess. That is well defined, and it might be something that's been derived from satellite data. It might be a compilation of different sources of information. It might be a decision support tool in that sense. So that is usually pretty easy to define, right? You're trying to do an impact assessment of something. That something is the piece of information that you're trying to evaluate. And so that is the information that you put in the blue column, okay, and in particular the first row of the blue columm. That's kind of the lightest colored blue square there. And then that is the state of the world in which the information that you are trying to assess is being used for decision making, right? And so then the next step is to go down one box to again, staying in the blue column, but the decision maker actions box in the blue column. What are the decisions that are being made using this information? Okay, and this is where things might not be as clear as, what is the piece of information that you're trying to assess, right? That again is sort of by definition already defined. But in some cases, you as the person who is trying to assess a certain piece of information, you might not know who is using that information or what kinds of decisions are being made using that information. And so this is where the research and fact-finding part of impact assessment begins. You need to figure out who the users are, and in particular, what decisions these users are making using the information. And the term decision maker and decision maker actions here is a really deliberate one in the way we designed this framework, because information ultimately generates socioeconomic impacts through its use in decisions. Okay? And so it is often not enough to just identify who the users are, because users of information might be doing it purely for their own edification or for a research purpose, right? So maybe it's a student who is using satellite data in order to write a term paper, right? But these aren't decision makers. Information needs to be used by decision makers who can take concrete actions that influence outcomes. And that is the logic that we want to lay out here in the blue column for the information that we're trying to evaluate. Okay, and as I foreshadowed, outcomes, right? What are the socioeconomic outcomes that people care about that are tied to environmental outcomes, right? What are those that are influenced by the decisions that incorporate the information? And that is what we put in the lowest column, lowest box here in the blue column. And so you can think about this, blue column as sort of following through the logic between the availability of the information that you're trying to evaluate, the decisions that are made using that information, and the consequential outcomes associated with that decision. Okay, and again, this may not necessarily be information that is readily available to you. You may be able to track the users of the particular piece of information that you're trying to assess, but maybe you have not done that yet, and so you have to go figure out who these users are. And then the next step is even trickier. What are the decisions that these users make? That's going to require some sort of conversation, some sort of perhaps some surveys, some listening sessions, some interviews with the decision makers. Sometimes these decisions are sort of codified or documented in guidance documents or guidebooks, right? And you could use those sorts of sources to figure out what these decisions are. But in any case, you have to go figure that out if you don't know that already. And then finally, what are the outcomes, right? And typically the decision makers can tell you what those outcomes are, right? Because they're making these decisions with a certain end, improving the environment, reducing poverty, improving human health, and so on. Let me just check to make sure that the chat is, okay, this is from a different meeting. Sorry, I was getting some alerts here on Teams. Okay, all right, so that is what we do in the blue column. In the red column, this is actually typically the more challenging part. This is, again, where we describe the state of the world in which the information that we're trying to assess is not available. Okay, so in that first row where we have to define the information in that world, the question that you're trying to answer is, what is being used by this decision maker in the absence of the information that we're trying to assess, right? And typically we think of this information as being in some way inferior to the information that we're trying to assess, right? Because we are coming with the idea here to the impact assessment that the information that we're trying to assess is somehow better than the information that currently exists. So what is that information that currently exists and is being used by the decision maker? Again, this may not be something that you already know. It may require some fact-finding, some research, some interaction with the decision makers themselves. It's typically one of the toughest parts of an impact assessment is some qualitative research in some sense to figure out who the decision makers are, and then what are these alternate sources of information that they would use if they aren't able to use the information that is being assessed. And then again, what are the outcomes associated with those decisions, right? If the decision maker uses this information that is an alternative to the information that is being assessed, how do those decision maker actions change and how do the outcomes change, right? Relative to what's happening in the blue column, where decisions are being taken using the information being assessed and the outcomes come out of those decisions. Okay, so I know this is a bit of a long description of this framework, but this is why we think it's such an effective framework, is that it packs a lot of stuff into one visual tool. And our sense here is that if you're able to fill in all of these 6 boxes for a piece of information that you're trying to assess the value of, then you're very well positioned to begin an impact assessment. This is basically a blueprint, or this will serve as a blueprint or a roadmap of your impact assessment. And we think as the consortium, this is a good exercise for anyone who is trying to understand the value of their earth science work to try to complete, right? Many of us are doing science to make the world a better place. Well, what is the logic behind how that information is going to make the world a better place, right? And when we mean a better place, relative to what, right? That's the red column. Okay, what else do I want to say? I do feel like I'm sort of going a little long here. It might be good to just get into some examples, right, Bethany, at this point. So yeah, why don't we go to the next slide? Okay, so Bethany and I have prepared 2 examples that we can use to fill out these impact assessments. And this is where we think this session will work out particularly well if we get some audience participation here, okay? And this is just an example. We're going to work on it together. There's nothing at stake here, okay? There are really no wrong answers. But hopefully this will be a process by which we can all think through this framework in a specific application, and hopefully that in turn will drive home the usefulness of this framework for any other kind of earth science application that you might want to do an impact assessment for. Okay, so we have these 2 examples, and what would be great is if after I describe the 2 examples, you could either type in the chat or just unmute yourself and yell out which one you'd like to do as a group. Okay, we may have time to do both, but just in case we don't, it would be good to get sort of the general preference of the audience. We'll sort of take an informal vote here. So yeah, after this is the first example, but after the second example, feel free to say which example you'd like to go in terms of an application of the framework. So the first one is, and I'm not going to go through too much detail in what these applications are, but just to give you a sense of what this data product is. So this is actually a data product that was supported by NASA Applied Sciences. It is a temperature data set, and the information was derived from the North American Land Data Assimilation System, and the information was used in order to provide the state of New York with more spatially and temporally resolute information on temperature. And I'm going to leave it at that. Basically, this is a remotely sensed a data product that is based on remotely sensed information that provides decision makers with observations on surface temperature. Okay, not surface temperature, but temperature, the kind of temperature reading that you might see in the weather report, right? But it leads to the kind of very detailed map that you see here for the state of New York. Okay, so that's the first example that we could go through as a group. Next slide, please, Bethany. The second one is a completely different animal in terms of a data set. It is one based on synthetic aperture radar, and it is basically imagery of ice conditions. Okay, so ice conditions in cold regions, and this I think is the Baltic, maybe the example here that's illustrated here, but this is a product of the European Space Agency, and the primary use here is for the imagery to be delivered to ships and icebreakers in these regions in order to effectively be able to create paths for ships in the winter. Okay, so these are regions. I'm not an expert on icebreakers and sea ice, but these are regions that cover where the ocean is covered in ice, and paths need to be created by icebreakers for ships to be able to move. These are both primarily cargo ships, and this data product delivers imagery of these ice, the ice, sea ice, to the ship captains on the icebreakers, as well as the other decision makers involved in how to manage ice conditions in these seas. Again, there's a lot more detail that could be given about these two examples, but I'll just leave it there because that'll give us a little bit of freedom to figure out how we might do an impact assessment of one of these examples. So yeah, those are the two examples, temperature and sea ice. And so feel free to type in the chat which one you'd prefer to do first, or just mute yourself and yell it out. And we'll just go by an approximate majority here.
Sorry about that. While folks are weighing in, I'm just going to switch over out of presenting mode use case so we can fill out the framework together once we select a topic. So bear with me a minute. The screen will probably go black. It looks like so far we have a lot of enthusiasm for the heat example.
Yeah, it's very timely too. A lot of hot places right now.
I think it's almost unanimous so far. Anyone else who hasn't had a chance to weigh in and feel strongly, please do.
Yeah, and again, we'll try to maybe get through the other one if we have time, but yeah, it does look like we're converging toward the heat temperature product.
All right, are you able to see the fillable framework again?
Mm-hmm.
Great.
I can. Okay, so yeah, let's get started. And again, audience participation would be great here. Yeah, the way we're going to do this is that I'll sort of keep an eye on the chat, and if anybody chooses to just provide an answer to one of the questions that I'll pose regarding the framework, I'll sort of moderate that while Bethany on her end will try to document in writing the ideas we come up with for the framework in writing here. So, okay, so let's just get started. So again, the blue column of the framework is the world in which the information, the data, the modeling that we're trying to assess exists and is being used for decision making, right? And everybody wants to do the temperature example. So in that box right there where Bethany's already ready to type in, we just put in that the name of the data set that we are trying to assess, right? So I guess we can call it the NLDAS temperature or based temperature information, something like that. We all know what we're talking about. It's that the data set that was referred to in that news piece on the NASA website that I showed earlier, right? Okay, so the easiest, well, I don't know what's the easiest way, but I think the most intuitive way is, especially in this case, is to sort of go downwards, stay in the blue column and try to understand who are the decision makers that might use this information. Yeah, this is where, actually in the article that I showed in the presentation, there is an example of a decision maker who used this information, but this is where, yeah, any hypotheses, any guesses as to where this information might be used. Yeah, if anybody in the audience has any guesses, we can put those in. Decisions to open shelters, right? So this would be like cooling stations or, yeah, air-conditioned facilities, right? Yeah, so that sounds like a really relevant decision, right? And in particular, because of the high spatial resolution of this data, right, where we would probably be able to do it in a fairly effective way, sort of, be able to target those communities that are particularly in need of those shelters, right? In some cities, they use city buses, right? They just drive the city buses to priority locations and allow people to just sit in the air-conditioned bus. And so if that is a decision that's available to you, that might be a really nice match to this, high spatial resolution information on temperature. I'm also seeing, I think I already have to scroll back up, energy providers and grid managers, right? Yeah, that's I think, I guess we had the example of Texas with the cold earlier in the year, but I'm sure there have been instances in other parts of the country with the heat waves of the high demand for electricity for cooling, leading to blackouts, basically, right? The wholesalers, electricity wholesalers and utilities not being able to generate the instantaneous demand. And so, yeah, I guess we can put, yeah, maybe this might be, in terms of decisions, helpful for figuring out which generators to run. I don't know what's the exact decision. What's the best way to describe the decision? But why don't we just put yeah, energy provision and grid management, the way Pete here has written in the chat. Places to focus cooling initiative: cool roofs, urban tree planting. Okay, yeah. So these perhaps are some how should we call it, like longer term decisions, right? So in contrast to say opening shelters, where you might need to make that decision on a fairly rapid basis. This would be sort of trying to figure out what parts of the state are sort of in general kind of in need of cooling features like cool roofs and urban tree planting. So yeah, thanks, Bethany. Hospitals, emergency rooms, right? So then this might be probably in terms of just making sure that the right resources, right, are at the right hospitals and emergency rooms, and that they're ready to address heat-related illness, for example. That's so there's yeah, I guess we could call that hospital and emergency room preparation. This is great. So we're already identifying a lot of decisions here. And okay, yeah, Sydney also mentioned sort of some of these kind of longer term solutions that help locations deal with more frequent heat events, right? Great. Well, I think that is plenty for the decision maker actions box. And so why don't we move to the last box on the blue columns, outcomes. Are you ready, Bethany? Yeah, there's a lot.
Sorry, just on mute there, I'm ready.
Yeah, a lot of great suggestions here. So here, we want to identify the societal outcomes, environmental or human health, poverty, environmental justice types of outcomes that are associated with those decisions, right? And so because we have a number of decisions that we were able to fill here in the decision maker actions box, we're going to have a variety of outcomes, right? So a lot of these are probably human health related, right? So reducing heat-related illness might be a good kind of catch-all term for example, the opening of cooling stations and hospital emergency room preparation. Yeah, and then for energy provision and management, so fewer blackouts maybe is the sort of the first order outcome that would be influenced here, though obviously the reduction in outcomes will have sort of other outcomes associated with it, right? And some which may be health related. So in particular, if people can't run their air conditioners because of the blackouts, then that would potentially lead to greater incidence of heat-related illness. And then, but it could also just be an economic cost, right? So if you are a factory that needs electricity to run and there's a blackout, then you've maybe lost some productivity there. So so the power outages might be associated with a number of socioeconomic outcomes that ultimately are what we want to quantify, right? So the power outages themselves may not necessarily directly describe what's most relevant for relevant socioeconomically, but what about the blackouts? So that's the kind of thing we want to put in the outcomes box.
And so Yusuke, should we say a reduction as well as a potential increase depending on what we're focused on here?
Right. So yeah, to the extent that better information about temperature can help avoid power outages, that will help avoid economic losses, or yeah, will enhance economic activity, I guess. Same thing. Okay. And I feel like some of these longer term solutions that have also been suggested, green, cool roofs, tree planting, green space, managing the urban heat island, right, in more permanent ways, are associated with a lot of these outcomes as well, right? And so, and you know, some an additional benefit of that might be less energy use in general during the summer because people don't need to run their air conditioners as long, for example, right? So yeah, a lot of different outcomes that can be influenced by the availability of the information, and again, each one of these outcomes ties to a decision, right? And that is why identifying the decision that is being informed by the information is really important, because it's really sort of the lever by which the information is actually influencing the outcome, right? Without identifying that decision, it's hard to make the logical step between availability of the information and the outcome that you're claiming as being associated with the availability of the information. I'll just note before we move on to the red column that this framework, as you may have already realized, it works the best if you focus on one decision at a time. So we had a lot of great and a large number of suggestions here for what the decisions are that might be influenced by the temperature information. But the way that you might approach using this framework on your own is to start out with one decision. So, for example, opening cooling stations, and then think about what that one decision that is informed by the information, what outcomes that one decision is tied to, right? And heat-related illness is going to be one of those. Yeah, then you can create several of these frameworks, right, to address the other decisions. I just suggest that because right now it's a little difficult to tell which outcome in that lower box is tied to which decision in the middle box, right? Again, it's great that we have so many ideas here. All right, so now let's move on to the red box. So what are these decision makers going to use in the absence of this remotely sensed information? So any thoughts as to how these decision makers who have less sophisticated information to make their decision, what kind of information they might use? So let's start with cooling stations, actually, just to provide a concrete example to focus on first. If the managers of those cooling stations, what kind of information might they use if they didn't have this this fancy data set from NASA? Previous experience. Yeah, that's definitely information, right? Accumulated information over time. And yeah, it's possible that basically the decision makers just always send the cooling stations to the same place, right? Because they're relying on previous experience. Yeah, any other ideas of? Yeah, yesterday's temperature. Yeah, so look at where it was the hottest yesterday and send the resources there. Number of people using cooling centers depending on temperature. Right, so so I guess that would require tracking how many people are using the cooling centers. Okay, yeah, so if you're collecting that data would also be helpful in addition to the temperature information, right? Hospitalizations at local facilities. Yep. So you might try to track, just the spatial distribution of hospitalizations. So yeah, a lot of information, and note, right, that a lot of this information, especially hospitalizations and the number of people using cooling centers depending on temperature, so the last two suggestions in the chat might actually also be used in the blue column too, right? So in addition to the satellite-based temperature information, decision makers might be using those informations about other things that influence the outcome, right? You know, maybe one thing to note here is that in implementing this framework, the key might be to think about the temperature information and identify what would be used for the temperature information in the absence of the satellite-based temperature information, right? And it might be, again, just looking at yesterday's temperature, previous experience with temperature, or just ground-based monitors, right? As it turns out, the that article that I showed you about this data product noted that previously the New York Health Department, who makes a lot of decisions about managing the health outcomes of heat, they use the ground-based temperature thermometers, basically, whatever is installed around the state in order to collect that information. That's how they normally do things, and so that could be one type of information that goes into that first box in the red column. Okay, so there are a lot of great suggestions here about what alternative kinds of information might be used, but if you were actually conducting an impact assessment of the satellite-based temperature information, then you actually want to go figure out what is the information that's being used, right? So you might need to reach out to agencies like the New York Health Department in order to ask them, how, thinking about cooling stations, for example, what information do you use in order to prioritize those resources? And they might take any of these different information sources that have been suggested. Okay, so all right, so I guess we're in our last 15 minutes here, so let's move on. Decision maker actions. So here, the decision maker actions are going to be in some sense parallel to what we've identified in the blue column, right? But we want to be able to qualitatively describe how they are different, and this is where, as you fill out this framework, you might actually need to go back to the first column in order to adjust your answer, just so that the difference is clear between these two worlds, right? So again, let's focus on these cooling station location decisions, right, and deployment decisions. So how are those the actions associated with those decisions? How are they likely to be different if the information in the first box in the red column is used as opposed to the information in the blue box, right? So instead, information that is used instead of the satellite information. So, the information that is used might be might have much lower spatial resolution, right? For example, if you're using ground-based temperature monitors, or if you're purely using past experience or yesterday's temperature as your guide, right? So cooling station deployment is likely to be determined at a much aggregate level. Say, maybe that's the best way to summarize that decision maker action in that world. Right, oversupplied or undersupplied would be the another way to describe the action there, right? And so this is where it might be good to go back to the first column, actually, the blue column, Bethany, and where we wrote opening cooling stations in the first line, modify that to opening cooling stations. Let's see, how can we make this parallel? cooling station deployment determined at a fine spatial scale, right? Which the enhanced data would allow you to do. And and then so maybe matches demand, maybe sort of to again make it parallel to the to contrast it to the over or under supply that would happen in the world with the without the satellite data, right? Okay. And so we could do something similar for all these other decision contexts, right? So energy provision and management. So we are with this, coarser information, temperature information, we are likely to be less able to manage energy and generation decisions at a fine temporal and spatial scale, right? Yeah, again, this is why I didn't want to get in too much detail into the specific data product, because then we have to fill out this framework in a lot of detail. This way we can be a little bit more general about it. And then, for that, we could go back to the the blue column decision maker actions and say determining energy provision management at a fairly fine scale, right? Yeah. Okay. I know there are other decision maker actions that y'all suggested, but yeah, in the interest of time, maybe we should fill in the last box here based on what we've been able to fill out in the decision maker actions box in red. So here, let's go back to the cooling station example. So so what is this over and under supply likely to lead to in terms of outcomes, right? So probably heat-related illnesses, right, are gonna occur because the cooling stations aren't going to be in the places where they are needed the most. So maybe we can say a relatively large number, or greater. Yeah. Yeah, and same for power outages, right? Relatively large number of power outages because the energy isn't being managed in as fine scale as would be possible with the more detailed temperature information. And so again, might be a good time to then go back to the blue column for outcomes and sort of make sure that the text makes sense, right? So instead of greater or relatively large number of heat-related illnesses, it would be relatively few, right? Yeah, thanks, Bethany. So yeah, as Bethany edits the blue column here for this box. This is basically we've completed the framework, and again, the idea is that we describe the two worlds, right? The world in which the information that we are trying to assess, in this case, the satellite-based temperature information, how that world unfolds, right? And in order to be able to describe that, we have to describe what the decisions are that are being informed by the temperature information, and then the outcomes that matter to people in the environment, heat-related illness, power outages, things like that, right? And then in the red column, how that world unfolds if that the information is not available. And the first step in that is identifying, well, if that information isn't available, then what is actually being used, right? And then try to see how use of that alternative information leads to different decisions and different outcomes. Ultimately, right, the societal benefit, right, the impact of the information is the difference between the two lowest boxes, right, the lowest blue box and the lowest red box. The way we filled this framework in, the societal impact is fewer heat-related illnesses and fewer power outages, perhaps less energy use overall, thanks to the availability of information. And you've, with this framework, described the logic behind, why that societal impact is likely to occur as a due to the availability of this information. Okay, and so this, seems like a lot of steps, but it actually doesn't. It's not that different from trying to document why some sort of, something that you might buy at a store, the value of that, right? Here we're trying to understand the value of information and the value of data, but this idea, this concept of having these two worlds is actually not that different from, say, what's the value of a car to you, right? The value of a car is actually very difficult to define if you don't understand what your world looks like without the car, right? So, the car may be very valuable to you if the only alternative you have is walking to work, and you live 6 miles away from work or something like that, right? On the other hand, if the alternative of not having of a car is great public transportation, then the value of that car is not going to be very high for you, right? And you very well may end up not owning a car, right? But again, it all depends on sort of that alternative world. The concept of value is meaningless in the absence of without understanding what the world looks like without that thing that you're trying to value. The one other thing I'll say here before we end is that here we're a little very qualitative, right, in our description of the impacts of relatively large number of heat-related illnesses in the world where we don't have the satellite information, and relatively few, right? It's still good to have that information and logic kind of laid out in this framework, but if you want to do a quantitative impact assessment, then each one of these boxes is going to need to be filled in with more quantitative information, right? And so in the world with the satellite-based temperature information in the blue column, you'd want to say something, 25 heat-related illnesses during July, something like that. And then
Oh, I'm sorry to interrupt you, Skye. I just wanted to point you to a question in the chat, but please finish.
Okay. The last thing I was going to say is that, if you want a quantitative measure of the impact, then you'll have to have quantitative measures of these outcomes in the two columns, right? And again, if you have, for example, 25 heat-related illnesses in the world where cooling station decisions are made using the satellite-based information, then you might identify that there are, 50 illnesses in the world without the satellite-based information, and that would require, again, an understanding of decision-maker actions, perhaps some information about how these decisions were made in the past and their outcomes. So that's where collaboration with a social scientist, if you're not a social scientist, might be really helpful in trying to nail down some of the actual measures. Okay, we have a question from Ashutosh. Right. Yeah, so that's a great question. So and this relates to sort of my caveat that this framework works the best for a single decision, but here we have multiple decisions and that we've been able to write in. And so, you would have to add up the benefits. There are, as you point out, sometimes when there are interdependencies. The benefits from one decision are sort of tied to the benefits in another decision. And so there you would, I think that sort of is a level of complexity that you can't really handle with this framework, but in an impact assessment study, you'd note, right, that perhaps the value of this information in two separate decision contexts doesn't entirely add up because the benefits overlap, for example. Yeah, so there are many ways in which this framework is probably too simple, but I think it's a good start for any or science application that you're trying to assess. So I know we're out of time. We only got through one example, but it's great that we were able to get so much audience participation here. Bethany has put up a slide with some additional information on how you can learn more about valuables, and a parting challenge for you. If you have an earth science application that you're trying to think about how to quantify its societal value, then you can fill out this form that we have prepared and that Bethany will share a link to in a minute. We will then, and that form will ask you many of the elements of this framework that we just went over. We will actually, be able to see what you wrote in, and we'll get back to you with sort of thoughts about how you might actually move forward with an impact assessment. But the form will basically get you started in the same way that this framework sort of gets you started on how to think about an impact assessment. Again, we could have done the sea ice example, but any earth science application that you're working on, and we should be able to arrive at some characterization of its societal value through the framework. So yeah, that's the parting challenge for you. All right, I know I'm a couple minutes over. Who do we hand this back to?
I'll take it from here.
Okay.
Thank you so much, Yusuke and Bethany, for the riveting discussion. Great presentation, and I personally think that the example was very helpful and helped me understand the framework a lot better than just explaining it outright. So I hope that everyone who was on the line learned something from this session, and I'll definitely be taking a look at that challenge. So thank you both so much for joining us today. It's been a pleasure.
Thank you, and thanks to everyone for joining us, and we hope you'll be in touch.
Thank you.
Thanks so much, Randy, for facilitating this session. I think we'll sign off, unless there's any follow-up.
Sounds good. Thanks everyone so much. Have a great day.
Thank you. Bye-bye.